Welcome to the Albuquerque Journal's Tech Outlook podcast. CNM is truly one college with infinite possibilities in tech and data sciences. CNM offers programs where everyone can learn about software, apps, or how to build websites. You can also choose from AI programs and machine learning, the Internet of Things, and so much more. CNM, one college, infinite possibilities, and the proud sponsor of the Tech Outlook podcasts.
Hi, welcome back to the Tech Outlook podcast. I'm Ryan Botel with the Albuquerque Journal, and I'm here today with Brian Rashap from CNM Ingenuity. Brian, thanks for being here today. Can we start? Can you just tell us a little bit about yourself?
Yeah, I came to New Mexico a little bit, almost 30 years ago. I grew up on the East Coast, ended up going into the Midwest for school, loved being a student, stayed at the University of Michigan and was collecting degrees, we'll say, and found an opportunity to come out to New Mexico. I can remember getting a phone call from Intel here asking me if I wanted to pursue a job in the plant in Rio Rancho and asked me what I knew about Albuquerque. And at that time, I told them I knew that Bugs Bunny made a wrong turn here, and I knew about hot air balloons, but I wanted to learn more. My wife and I moved out here in the mid-'90s after I had done some work at NASA and had decided to move into the semiconductor industry. And both of us were engineers at the Intel facility. I spent a little bit over 2 decades in various jobs here locally at Intel, and then my last few years of my Intel career, I was responsible for Intel's facilities across the U.S. and Canada, so I got an opportunity to see a broader spectrum of things. In all honesty, I got tired of being in airplane seats often and decided it was time to just be here. Left Intel early in 2019. During my education, I always wanted to teach, and I found myself going into industry mostly out of a curiosity of, do people care what you're getting taught in school? I found a really great mix of being a technical manager, so being able to teach younger engineers and others within the organization technical topics and how to problem solve and stuff. And so when I left Intel, I was very fortunate to come across this opportunity at CNM to really, in some way, fulfill my lifelong dream of being a teacher and to be able to give back to the community and give back to the prospective students and help people get into high-tech jobs maybe that they thought that they weren't prepared for.
Yeah, and one of your jobs at CNN is you're an educator who teaches the Internet of Things boot camp. To start off, can you tell us what the Internet of Things boot camp is?
Yeah, so first, the Internet of Things, which is a term that often doesn't make a lot of sense to people. You can really think of Internet of Things as smart connected devices, and you have many of them in your home. You might have a doorbell that has a little camera in it, and these days can detect if someone's bringing a package to your door. You have a smart thermostat that optimizes the temperature control in your house. You may have smart irrigation that looks at the weather forecast and decides whether or not you should water your plants or not. All of that are smart connected devices. A smart watch, fitness trackers, all those devices that are connected to the internet or connected to your phone and do something to make your life easier. That would be the Internet of Things. We developed the Internet of Things boot camp as a way to help individuals get started in that industry, and particularly individuals that a 2-year program just didn't fit their needs of their life. And so the boot camp is part of CNM Ingenuity's deep dive program. They're 10 to 12 week immersive training. So I get students 40 hours a week for 10 weeks, almost 400 hours. And the students go through and they learn a variety of things. They learn how to program. They learn how to do electronics design. They learn 3D printing, 3D modeling, rapid prototyping, a variety of skills that prepare them to go into jobs where either they're creating these smart connected devices or using the smart connected devices to make something better, say a manufacturing process.
And to me, I mean, 10 weeks doesn't sound like a long time to become, knowledgeable on these high technological skills. Can you just give us a sense of how the program is formatted for the students?
Yes. So first and foremost, which is very important, is that we don't require any prerequisites for the students. You don't need to have a science background or a programming background. I tell individuals that are looking at our Internet Things class, there's really two things that you need to know. You need to know what a mouse is on your computer. And if you pull out your phone, if you can divide, then we'll teach you everything else. And it does seem like starting from that point, how can you get into a tech job in 10 weeks seems like a stretch. But because we're doing it in this immersive environment where you learn maybe the theory of something and then you're immediately applying it. So I don't spend, like in a traditional classroom, there's a lot of lecturing, there's a lot of doing homework, there's a lot of doing book work, and maybe there's a lab class that goes with it where it's hands-on. This is flipped around. It's mostly hands-on, doing work with yourself and with your peers. You get a little bit of instruction, you apply it, you get more instruction, apply it, and we literally do that over and over again for the 50 days throughout the course. Because it's in that intense environment, the boot camp makes you think of kind of like a military boot camp.
Sure.
And it's the mental equivalent of what that physical activity is. You're going through this experience where you're just so immersed in what you're working on and you see it so many times so quickly that we're able to accelerate the ability of people to learn.
Okay, great. Maybe we can dive into one of those. You mentioned 3D printing and 3D modeling. So as part of this boot camp, to start off, can you just explain what 3D printing and 3D modeling is?
Right. So 3D printing is, so traditionally when you do manufacturing, you may start with a piece of wood or a slab of metal and you put it on you use a drill to drill out a hole, you use a saw to cut it, you maybe mill out pieces. And so you have this starting object that you subtract things from to make the thing that you want ultimately to have. 3D printing is a class of manufacturing that's called additive manufacturing, where you start with essentially a clean slate, in our case just literally a plate, and you put down layer by layer of material. So almost like icing a cake. So you're just putting down that icing and putting down layer over layer over layer of that, and you're making an object. Now, in order to do that, you need to have a design of what you're creating. And so the 3D modeling is a computer-aided design type of skills where you take something that you're envisioning or something that you're trying to recreate, you take the measurements of that, you create on the computer a three-dimensional representation of it that you can rotate around and you can connect to other objects, make sure that it's what you want, and then you're able to send that file essentially to this 3D printer, just like you would send something to your printer at home. And instead of just printing on a piece of paper, it'll make it layer by layer by layer and match what you've designed on the computer.
Okay, wow. And what would the advantages of 3D printing be over more traditional manufacturing?
There's a couple advantages. Probably the easiest one to comprehend is in the space of rapid prototyping. So if you have an idea for a product, traditionally what you would do is, design the product, make mechanical drawings of it, get it sent out to someone to manufacture that part. It would come back. It might be a little bit off from what you were envisioning. The 3D printing capability or additive manufacturing capability allows you to rapidly, almost literally on your desktop, actualize that thing you're thinking of so you can make more and more improvements to it faster. So in terms of rapid prototyping, this additive manufacturing works. Secondly, it allows you to have a big variety of materials and techniques that you can build things that are hard to subtract out of stuff. An example that maybe many people have come across that's in the 3D printing realm is if you ever had to go to the dentist and have a crown put in, the dentist goes in and they take images of your teeth and they give you like a temporary crown. It used to be something they had to ship out. These days, many dentists have these 3D printers in their offices. They'll image your tooth before they do their dental work, and they'll literally print the tooth, put it in your mouth, and let you walk out of the dentist office within minutes of that, to have that, that at least that temporary tooth while they're making the permanent one. And so that's a way that 3D printing has kind of come into people's lives.
Yeah. Well, you're speaking to the choir. I actually have a hole in my mouth because I have my tooth that my dentist is gonna print and put in me later. So it's just kind of wild. So there are these little things that people don't even necessarily realize. There's 3D printed objects around us in the world today.
Absolutely.
And so with these students, I mean, and we can just stick to the 3D printing, they go through this boot camp, they learn these skills. What's waiting for them at the end of the 10 weeks? How could they apply that in a professional setting?
Yeah, our mission is workforce development, and we are looking to get our students directly into employment. Our students in general come from non-technical backgrounds, or maybe they come out of the military and are looking for a refreshing of civilian skills. And we've been very successful at placing the students that come through the IoT boot camp and some of our other boot camps into local businesses. Mm-hmm. I have graduates that are at what we would traditionally think are the big companies at the national labs, both Sandia and Los Alamos, at Meta down in Los Lunas, at Intel up in Rio Rancho. So we've placed students mostly into technician type jobs, so working on the manufacturing line, or in the case of Sandia, working in being a lab manager in one of their technical labs. We have students that have gone to medium-sized companies. One of my recent graduates works at Redwire Space, and he's doing 3D modeling, 3D design for some of their satellite programs.
Okay, wow.
There's a variety of startups in New Mexico that have hired our students as well. Some that work in the Permian Basin, some that work in robotics locally. We've had a number of students go into what you would think of as the immersive entertainment space. Think of like the Meow Wolves or the IDMs of the world. And so our students tend to go into a variety of spaces, mostly like high-tech manufacturing based, or but a little bit broader than that.
Okay. Do you get a sense that the local major employers are recognizing the quality of these workers, and do you see these types of jobs increasing in the future?
I definitely feel and have seen that local employers are starting to see the value of students coming out of this program. When I was at Intel, I needed employees of kind of all different levels. So I needed folks that had gone really advanced degrees, and I needed folks, more importantly, that could turn a wrench and work on a high-tech piece of equipment. And so we're filling different gaps within the local workforce, not all of them, but different ones. Many of our employers have not only hired one student, but have come back for more students. So that's a great indicator that they are happy with the quality that they're getting. And we've also been able to upskill individuals that employers wanted to hire. So let's say veterans coming out of Kirtland, we're able to do a little bit of upskilling to them and get them into civilian jobs. And that is kind of a win-win both for our veterans and also for our employers to be able to take someone that has some really deep, great knowledge that they got in the military, get some civilian skills, and be able to apply that to the local economy. Okay.
And for the Internet of Things boot camp, there's one coming up next month. Do you want to tell us about that? Is there any availabilities still in for that course?
Yeah, we run the Internet of Things boot camp 3 times a year. So essentially in the fall, the spring semester, which starts in February, and then in the summer. So we have in the middle of June, the next Internet of Things boot camp will be starting up. It'll run through August. We have seats available in the class, and maybe more importantly, thanks to the state and other funding agencies, we have funding to pay for the tuition for the students.
Okay, so there's scholarships available.
There are scholarships available, yes.
Okay, great. And where do people go to get information about that?
There's a website, deepdivecoding.com/IoT, which has the information about particularly the IoT bootcamp. If you just do deep dive coding, it has information about all of the deep dive programs that we have.
Great. And we did want to have you on to talk about Internet of Things, but we also wanted to talk about this quantum boot camp, because you're developing this quantum boot camp that will be a new addition to the CNM Ingenuity boot camp programs.
That's right. Yeah. As we think about our portfolio of trainings that we have, we're always looking into the local economy and industry and asking what's next. What do we need to prepare the workforce for? There's the chicken and egg of, companies won't come to a town unless there's a workforce, but you don't develop the workforce until you have the company.
Yeah.
And so part of the CNM processes is to really look towards the future, look what's on the horizon, particularly in technology, look for opportunities where New Mexico can really differentiate itself. And quantum computing or quantum information systems is one of those areas.
Okay. And to start, can you try your best to just explain quantum computing to an everyday person?
Yeah, we're all familiar with conventional computers. You have, word processors or spreadsheets, even big data of, keeping track of records and bank statements and all that type of stuff work phenomenally well in conventional computers. But there are a set of problems that conventional computers, even though they're fast, still take a long time to solve. And so a few examples. If you're a healthcare company or a pharmaceutical company developing new drugs, the process these days is to kind of simulate the drug and its interaction with different things in the human body. And what they do is they basically literally, similar to our 3D design, they create a 3D model of the drug molecule, and they simulate how it would interact with, let's say, a virus. Mm-hmm. And as you might imagine, it's a very serial process. I have to change the drug. I change a molecule. I test it. I change something. I test it. I change something. Test it. Quantum computing has the possibility of essentially testing all the different variations all at the same time. Okay. And so it can speed up problems like that. Another one that I think is, near and dear to all of us is that, over the past few years, it's been at times hard to get products and things because of all this supply chain disruption around the world. And there are some traditional techniques to optimize how you get something from point A to point B. And again, quantum computing allows you to essentially all at the same time test all the different paths and find out which one's the most optimal. Mm-hmm. So in these sets of problems where there's lots of possibilities, quantum computing really is going to be a game changer in allowing us to really optimize and change the way that we do stuff.
Okay. And quantum theory, the study of it, has been taking place in New Mexico for quite some time. There's a history of it here, right?
Absolutely. There's really great quantum programs at our higher educational institutions. We have both national labs have been at the forefront of this kind of quantum revolution since they've existed. And so we definitely have a great base, but we don't have a lot of but it's mostly research right now. It's academics and it's research. And over the next 10 years, we believe, and the data suggests across the country, that there's going to be this really fast expansion or inflation in the need for quantum jobs as quantum moves from the lab and into the workplace and into the commercial sector. And that's really what we're targeting.
Okay. So Albuquerque in New Mexico has this history of academic research into quantum, hasn't really been applied from a business level with technicians who can, I guess, advance that research and theory into something practical? Or
yeah, and just to make a distinction, there are quantum processes in everyday stuff today. So like the way that your cell phone stores pictures takes advantage of quantum mechanics. The way a traditional computer works takes advantage of that. But we're talking about, in this case, a different way to think about computing using these quantum ideas. Academically, New Mexico is very strong. In the labs, we're very strong. And really, we're hoping over the next few years that we'll see a transition of that into the commercial sector.
Okay. So then how are you developing this program to create, a quantum technician who is hireable in 10 weeks if we don't even necessarily know what that industry might look like in the coming years?
Yeah, from the work that happens here already and from the work that happens in other other quantum centers of excellence, if you want to call it, other areas of the country where there's some quantum expertise. We know some of the base skills that are needed that will be used when this quantum computing revolution happens. And so as we think about developing this quantum boot camp, we really looked at some fundamental skills that we believe are not just applicable to quantum computing technicians, but semiconductor technicians, solar technicians, the defense industry that we have here. And so we're creating this program that takes essentially three different concepts. It takes this idea of that there's a class of quantum computing that takes advantage of lasers and fiber optics, lenses and mirrors. And so we're going to train individuals on how to do that, how to do those types of skills, again, applied towards quantum computing. Most of the quantum computing activity either happens at very cold temperatures or in chambers that are essentially evacuated of the normal atmosphere, and you are able to introduce things one atom at a time. And so we'll be training individuals on what's known as these high vacuum systems, so extremely low pressures. Both of the lasers and optics, the vacuum systems, again, are used in semiconductor and solar and in defense. And then we'll take those two sets of skills. We'll then teach students quantum phenomena, similar to what someone that's going through a sophomore or junior level quantum mechanics class will read about in a book, and we'll explain the phenomena, book style, but then immediately be able to have the student create that quantum phenomenon for themselves. So use that idea of deep immersion, and then kind of combine those three things. So I combine laser and optics, and I combine vacuum systems, and I combine the understanding of quantum phenomena, and we won't be able to build quantum computers per se, but we will be able to build essentially the building block of a quantum computer and give these students the skills they'll need to be in that workforce.
Yeah. And that is, I mean, it kind of can't be overstated and is pretty amazing that you're talking about very complicated theories and processes, and the prerequisites for this is to know how to use a mouse and a calculator.
Exactly. And by design, because we are... one of the things that I have found is there are so many people that are self-selecting out of the high-tech workforce. I wasn't good in science. I'm not good in math. I didn't have this experience. And so really fundamental to the design of our courses is to really reduce all those barriers to entry and to show everyone that there is a place for them in this technological future of the country. And not everyone's going to choose it, but for those that want to go down that path, we've really just stripped away everything that can be in their way and tried to find a great path that can show that, honestly, literally anyone can be involved in our high-tech economy.
And I guess, Brian, to close out, you're developing this quantum program for CNM Ingenuity, this boot camp. What is your goal for the years ahead if this takes off and is successful like your other boot camps have had? What will that mean for the Albuquerque economy?
We are fortunate enough that we're able to build this boot camp in conjunction with some of our partners, the academic institutions and the labs. And so we're hopeful that by creating essentially this non-PhD workforce in quantum, today 95% of the people working in quantum probably have PhDs. So creating this kind of not even needing a bachelor's to be in the quantum space, will first start to attract companies here because we have the workforce from, the theoreticians that come out of the academic institutions to the hands-on engineers, and then most importantly, these technicians that are really going to make the equipment work. So we'll have that workforce. We'll build upon the expertise that we have in New Mexico and start to attract companies and have homegrown companies and really start to be a hub for this quantum revolution.
Okay, great. Well, that was fascinating. Brian Rashap with CNM Ingenuity. Thanks for coming on today.
Well, thank you very much, Ryan.
All right, have a good one.
Thank you.